So this is going to be the fifth section of Chapter 7 for geometry. This is going to be dealing with parallel lines and their properties again. So we dealt with parallel lines in the past about their angles that they make, like corresponding and alternate interior and linear pairs and stuff like that. Well, I guess linear pairs isn't just parallel, but anyway, we talked about the angles that they make. Now we're going to talk about how they interact with segments. So let's go ahead and get to it. There's basically four main types of problems we're looking at, four main types of situations. So the first one is about how they interact with these triangle situations. So the first one's called the triangle proportionality theorem, and the second one's called the converse of that. So the triangle proportionality theorem basically says that if you have two lines and they're cut by two parallel lines, then the segments that you result with are proportional to each other. So if we assume that BE and CD are parallel, which is why those arrows are there, that means that the ratio of AB to BC is going to be the same as the ratio of ED and or AE and ED. Basically, what that means is, like, say this length was 1 and this length was 2. So this length is 1, this length, so AB is twice as much as BC, right? Well, that means that the same holds true down here. That means that if this was 3, then this would have to be twice as much, which would be 6. So it's not that they're the exact same length. It's not like it's 1, 2, 1, 2. It's that the ratio, the way you get from BC to AB, which is times 2, is the same as the ratio from here to here, which would also have to be times 2. Or it can be times 4, times 5, we don't know. But that's what the theorem is saying, is that the way you get from one segment to the next is the same for both the top pair and the bottom pair. The converse is just the reverse of that. The converse says that if the ratio is the same, so if the ratio is true, then the lines are parallel. So again, this would be like if you're using a proof and they said that prove AC and ED are parallel. Well, to do that, you would prove that AE and EB and then CD and DB form the same proportion. Um, so this also holds true, by the way, for the across sections as well. So another side theorem here is that the ratio of AB to AE would be equal to that of BC and ED. So you notice here 2 times 3 is 6, and then 1 times 3 is 3. So the up and down ratio is the same as the side-to-side ratio here. So let me put this into context here, and let me make sure I try to adjust this picture here so it can look a little bit better. A little bit off screen there. Let me see if I can't shrink this down a little bit. And there we go. So it says if PS is 12.5, so P to S is 12.5, SR is 5, PT is 15, find, it says TQ there, find TQ, so find X, essentially. So we know that these lines are parallel, so that means that we have the, sorry, hiccup there, that means we have the following ratio. We have that PS, 12.5, to SR, 5, so top to bottom is going to be equal to top to bottom, 15 to x. So again, that's what this ratio, that's what this fraction bar here means, is that 12.5, going from 12.5 to 5 should be the same as going from 15 to x. I just don't know what x is. So I set it up as a ratio, and then I can cross multiply and figure it out. So that would be 75 is equal to 12.5x. Divide by 12.5, we get x is equal to, so 75 divided by 12.5, we get 6. So x has to be equal to 6. And again, to show that here, if you want to check your work, what you would do is you would ask yourself, okay, 6 times what is 15? Well, let's do this. 6 divided by 15 is 0.4. So, actually, I should probably do this. 15 divided by 6 is 2.5. So that means that 6 times 2.5 is 15. Well, that should also mean that if I take 6 times 2.5 to get 15, I should be able to take 5 times 2.5, and that, whoops, 2.5, and that should get me 12.5, which it does. So you can check your work that way to make sure that the ratio is consistent. So now this one's a little the same kind of problem, but it's a little bit tricky. It says DG is half the length of GF, and it says EH is 6. Let me go ahead and mark that down here. EH is 6, and HF is 10. Is DE parallel to GH? So it's asking if these things are parallel. So now remember, in order for these lines to be here, DG and GH, in order for these lines to be parallel, that means the ratio of EH to HF has to be the same as DG to GF. So this multiplier has to be the same as this multiplier. Now let's first figure out what the heck this multiplier is over here, just for curiosity's sake. So 10 divided by 6 is 1.6. So that means that 6 times 1.6 repeating, just having a bunch of 6's there, is 10. So 6, this is a times 1.6 repeating. So this multiplier, this scale factor, should be the same as over here. So what is dg? Well, we don't know what dg is, but we do know that's half the length of gf. Well, okay, let's just say gf is x, because we don't know how big gf is. Let's say gf is x. How big would dg be? Well, dg would be half of x, right? Because it says dg is half the length. All right, so gf is x, dg is 1/2 x. Is that a multiplier of times 1.6? So basically, is 1/2 x times 1.6 equal to x? Well, no, 1/2 times 1.6 is going to be some weird number, and that's definitely not going to get us equal to x. So just to prove it to you here, if I take 1/2, which is 0.5, times 1.6 repeating, I end up getting 0.8. So I get 0.83 repeating x, not 1x. So this would be a no here. Because the multiplier over here on this side is times 1.6, the multiplier here over this side is actually times 2. 1/2 times 2 would get me 1x. So 1/2 x times 2 would get me 1x. But I need it to be 1.6 because that's what the multiplier over here is. So this would be a no-go there. If you want to do it the other way, you could just set up the ratios and see if they come out to be a true answer. So you could set it up like this. dg to gf, so 1/2 x to x is equal 6 to 10. And then you cross multiply. You get 6x is equal to 1/2 x times 10 is 5x. Subtract 5x, subtract 5x. You get x is equal to 0. Well, x can't be 0 because this length gf can't be 0. You can't have a length of 0, otherwise it wouldn't be on the diagram, it wouldn't be existing. So that's how you would know that would also be a no, is that when you get a nonsensical answer for x, like a 0 or a negative number, that just can't happen as a length. So the last two things that we're going to do with parallel lines here is mid-segments and triple sections. So basically a mid-segment is just another piece of a triangle. So a mid-segment is a segment that cuts the two sides it connects in half and is parallel to the third side. So JK here is a mid-segment because it cuts the two sides of the triangle that's attached to in half and it's parallel to the side that it does not. Now it also happens to be, this theorem here says that JK is half the length of FG. So if FG is 10, JK would be 5. If FG was 100, JK would be 50, and so on and so forth. So again, the requirements are that JK has to be a mid-segment. It's not the same thing as a midpoint. It's not the same thing as a median. JK is a mid-segment in that it connects the midpoint of one side to the midpoint of the other side and is parallel to the third. Okay? And then once we've established that's a mid-segment, then we can say that the bottom piece is twice as big as the mid-segment, or the mid-segment is half as big as the bottom piece. Now, the last one here is basically taking what we did in the previous examples and just expanding it to 3 or more. So this holds true for not only 3 parallel lines, but if you have like 5 or 6 parallel lines, the same thing holds true. Is that if you have 2 lines, or more actually, but if you have 2 lines and they're cut by 3 or more transversals, then they're cut proportionally, which basically, as it says here, basically means that the ratio of, like, let's say this side right here, AB, the ratio of AB to BC is going to be the same as the ratio of EF to FG. So once again, if this was 4 and this was 8, then this would have to be something like 10 and 20. So again, times 2 here means times 2 here. And again, it also means that the left and right is true as well. So AB to EF is going to be the same as BC to FG. So you can go side to side as well. So 8 over 20 is the same as 4 over 10, essentially. But again, that's just basically what we just did in the past example. In this example, it's just expanding it to when you have 3 or more cuts rather than just 2. Okay? So let's take some of these and practice them a little bit. So find each measure. So we have this triangle that's marked quite a bit. It says find the measure of DE. So where's DE? So DE is right here. We want to find out how big that is. Well, first thing we should notice that it is a midsegment. It connects the midpoint of this side to the midpoint of this side and is parallel to the third side. It doesn't tell us that, but we know. I think I cut it off in the top picture there. So because we know that it's parallel to the third side and it connects the two midpoints, that means the midsegment, and we know that midsegments are always half as big as the third side. So this midsegment DE here is going to be half as big as this segment over here for AC. Well, if AC is 15, that means DE has to be half of 15, which is going to be 7.5. So again, midsegments are always half as big as the side that they're across from. Okay, so what about DB? Okay, this one's a little bit trickier. DB, which is this piece right here. We know that DB is congruent to AD because, again, they're marked as congruent there. Let me get my eraser here and erase some stuff here. All right. And then there we go. So we want to know how big DB is. Now, here's what to do. Again, do a little bit of math voodoo here. FE is also a midsegment. FE connects the midpoint of this side to the midpoint of this side. So if FE is a midsegment, that means 9.2 is half as big as the entire third side. So that means that this entire third side is 18.4. Okay? So again, 9.2, half as big as big side, 18.4. Well, if this side's 18.4, and these are both half as big as that, because again, they're both marked as congruent, so they're both half as much as the full segment, that means this also has to be 9.2, because it's half as much as 18.4. 9.2 for this side, 9.2 for this side, 18.4 for the full length. So you had to kind of use the mid-segment to get the entire length of this side, and then cut that back in half to get the segment that you wanted, which was DB. And excuse me, last piece they want to do is find out the measure of FED. So let me erase all this stuff here so I have a little bit easier time writing. FED, which is right down here. They want us to know the measure of this angle. Want us to figure out the measure of this angle. Call it X here. How big is X? Okay, so let's look here. It's going to be kind of hard. Now, I do know that this angle right here is 82 degrees, which is good. Now, once again, remember that this line right here is parallel to this line over here, because again, midsegment is parallel to the third side. And this line right here, FE, is kind of acting as a transversal. So if you do a little creativity here, you can see that if I go up this transversal, down this one, and up this parallel line, I have a sort of Z pattern going on here, right? This sort of Z shape. And I could also do it in the other direction as well. So here, that means that this corner angle FED is going to be congruent to this corner angle CFE, but I don't know how big CFE is. That doesn't give me much. But what if I do it on the other side? So DE is not my only parallel midsegment. I have FE parallel to AB, because again, those are also midsegments. So if I go up this line here, down the transversal, and up this line here, I get another Z pattern. And in this case, my Z pattern actually does include 82 and this mid-C segment here. So I know that FED is going to be equal to 82 degrees. Okay. So again, look for parallel lines. And remember, if you have parallel lines, look for vertical, corresponding, and alternate interior angles. So that Z shape is that alternate interior angles bit there. That one required a little bit deeper inside of the triangle there. So that one's a little bit trickier one. All right, let's look at this one. This one's the triple split one here. So if all three of these lines are parallel, that means I know that the ratio from here to here is going to be the same as the ratio from here to here. So as a fraction, look like this. 8 over 8, this over this, is going to be equal to this over this. It's going to be equal to 7x minus 2 over 4x plus 3. And then we cross multiply. So we get 8 times, now again, this 8 is going to be multiplied to both terms here. So it'll be 56x minus 16. And over here, it'd be 32x plus 24. So we simplify this equation or solve this equation. So minus 32x. 32x, get my x's on the same side. We get 24x minus 16 equals 24. Plus 16 plus 16, we get 24x is equal to 40. And divide by 24. Divide by 24. So let's check my math here a little bit. All right, and then divide by 24. We get 1.6 repeating. So x is equal to 1.6 repeating. Now, if you want to check your work, or if you just want to do this a different way, you could also know that what's the ratio from 8 to 8? Well, 8 to 8 is just timesing by 1, right? 8 times 1 is 8, which basically means that these two sides are congruent because they're the same length. That's what it means to be congruent, is you have the same length. Well, if these two sides are congruent, that means that these two sides also have to be congruent because they have to be in the same ratio as the other ones. So this would also be a times 1 situation, which basically means that the two sides are the same length. So instead of doing it like this, in this case, because I know that they're congruent, I could have set it up as 7x minus 2 equals 4x plus 3. And I would have arrived at the same answer. So I would divide or subtract here, I get 3x equals 5, divide by 3, and then if we type this in here, 5 divided by 3 gives me also 1.6 repeating. So in this case, if you know that one pair of sides is congruent, then the other pair also has to be congruent as well, because once again, they have to share the same ratio, they have to share the same scale. All right, this one's kind of like the ones we did earlier in the video. Now again, we have the same trick here. We know that this side is congruent to this side, so these two sides are equal, which by extension, since these two sides are equal, that means that these two sides also have to be equal. This side right here has to be equal to this side right here because the ratio has to remain consistent. If this is a times 1 ratio because they're equal, then this would also have to be a times 1 ratio because they're equal. So I could just, instead of setting up a fraction, which I could do, but instead of setting up a fraction, I could do this. 3y equals 1/2 y plus 20. Solve this one. And then for the x's, I'd be 20 minus 3x equals 2x minus 5. And solve for that one. So in this case here, I would get 2.5y is equal to 20. Divide by 2.5. Divide by 2.5. We get y equals, it'd be 4, I believe. Or not 4, but 8. 4 would be a 10. So y is equal to 8. And then over here, we'd have 25. If I add the 5 to this side, is equal to 5x. If I add the 3x to here. So add 3x to this side, add 5 to both sides, divide by 5, divide by 5, we get 5 is equal to x. So again, this is another case where if one pair of sides is congruent, then the other pair has to be congruent automatically, because if these lines are parallel, you have to have the same ratio, the same scale from one set to the other. So let's do another one here. It says in triangle ABC, let's mark these down here. BC is 15, so BC is 15. BE is 6. DC is 12, and AD is 8. Determine whether these two lines are parallel, DE and AB. Determine if they're parallel. Well, first off, if the entire thing is 15, I know that this side's 6. That means this side over here has to be 9, because 9 plus 6 would have to add up back to 15. So just to get that out of the way first. Now, if I want these two lines here to be parallel, that means that this ratio here has to be the same as this ratio here. So I'm going to set up a fraction and see if it's true. Is 6 to 9 the same as 8 to 12? Are these the same? So let me cross multiply and see if I get the same number. So 8 times 9 is 72. 6 times 12 is also 72. So if I get the same answer when cross multiplying both sides, that means that it checks out, which means that yes, the lines are parallel, because this ratio ends up being the same as the bottom ratio. Or you could do it in the calculator and check exactly. So 6 to 9, is that the same as 8 to 12? Yes. So because they come out to be the same decimal, you know that the ratio, not the numbers themselves, but the ratio is congruent, and therefore the lines have to be parallel. So again, 6 is not congruent to 8, 9 is not congruent to 12. It's the ratio of how to go from 6 to 9 or 9 to 6. That is the same as how to go from 8 to 12 or 12 to 8, respectively. So you're not saying that the segments are congruent, you're saying that the way to get from one segment to the next is congruent. By multiplication, not by addition. So let's do another one of these mid-segment ones here. So JH is a mid-segment. Find the value of X. Well, again, this one should be pretty straightforward. If JH is a mid-segment, that means this mid-segment has to be half as long as the side it's across from. So if this entire side is 22, that means this has to be equal to 11, which is just half of 22. So that's it. Again, these can go very quickly because if they ask you how long a mid-segment is, your goal is to find out how long the opposite segment is and then simply cut in half to get how long the mid-segment is. Mid-segments are always half as big as the side that they are across from. Or put another way, the mid-segments are always half as big as the side that they do not connect to. Let's do one more here. So once again, we have that little trick here where I say that these two sides are congruent. And I say that all these lines here are parallel, and then I ask you about these two sides. Or in this case, I'm asking you about both pairs. Well, if these two sides are congruent, I automatically know that I can set this up as just one big equality. So 12 minus 3y is equal to 16 minus 5y. I mean, if they're congruent, might as well set them equal to each other. But I also know that because these lines are parallel here in the middle, that if these two are congruent, that means these two have to be congruent as well. So not only can I do that for the y's, I can do it for the x's. 1/4 x plus 6 is equal to 2x minus 29. And then I can solve this one through. So just to be quick about this here, this would be 6 is equal to minus 1/4 on both sides would be 1.75x minus 29. Add 29, add 29. We end up getting 35 is equal to 1.75x. Divide by 1.75. We get x is equal to 35 divided by 1.75. 20. So x is equal to 20. And then over here, that doesn't mean that y is equal to 20 again. Doesn't mean that x and y are equal, just means that the segments are congruent. So if x is 20, we have to go over here and figure out what y is using its arithmetic. So I'm going to add 5y to both sides, and then subtract 12 from both sides, just to speed this up here a little bit. So that'd be 2y is equal to 4, divide by 2, and we get y is equal to 2. And that's my answer. So once again, if one pair is congruent, that means the other pair is automatically congruent as well. Now, I want to do one more here that I didn't put on here. So let me draw one here real quick. Let me make a new slide here. Let me stop my show here for a minute. And then let me make a new one. There we go. And then let me bring this back up. There's probably an easy way of doing this, but oh well. So one thing that we didn't quite get into is what if they're not always congruent, because they're not. We think we did one or two of these, but I just want to do one more before we go. So let's say I draw two lines here. We have three lines that cut them, and I say that they're parallel. If I say that this line here is 12 and this line here is 20, and I say this is x and this is, I don't know, 26, and I say find how big x is. Well, obviously they're not congruent, but what I can do is set up my ratio. So it goes top to bottom, top to bottom. So 12 to 20 is equal to x over 26. And then you cross multiply. So 20x is equal to whatever 26 times 12 is. So 26 times 12, get 320, or 312 rather. Then divide by 20, and we get x is equal to whatever 312 divided by 20 is. Divided by 20, divided by 20, and we get 15.6. And then that's that. So if they're not congruent, you set up the same way we've done all our scale factor problems, set up a proportion. If you haven't noticed by now, this whole similarity chapter has always been about, or most of it has been about setting up a ratio kind of like this for different pieces and cross multiplying to solve for a variable or a side or something like that. So that's no different in this case here. So once again, if you need to go back through this video and make sure you recap the theorems or whatever, go ahead. If you need questions, let me know. Otherwise, hope you enjoyed the video. Have a good day, night, or afternoon.